Hey there, this is Mr. Baker, and this video is on solving systems of inequalities. The one skill that I see that students have that struggle with for solving a system of inequalities is that they can't graph just a regular inequality by itself. So I always cover that first. And there's really three things you need to know to graph an inequality. You have to know where the line goes. I usually put my equations or my inequalities in slope-intercept form, and then I just pick out the y-intercept and slope and put those points on there. But I don't graph it yet, because then you're going to have either a dotted line or a solid line for your boundary line. A dotted line shows that the points on that line don't work for the inequality. A solid line shows that they do work for the inequality. The inequality will be in your problem either less than or equal to or greater than or equal to if it's going to be a solid boundary line, or just less than or greater than if it's going to be a dotted line. Last thing you need is shading. The shading shows where the points are that work, that fulfill and make true statements for that inequality. That'll be above or below your boundary line. So let's do a couple examples. This is out of my book that we use at my school. It says x is greater than or equal to 2 and y is greater than 3. Here's another misconception. A lot of students see that x and they think, oh, it's going to be a horizontal line because they know the horizontal x-axis, but it's actually backwards from what you think. But you're looking for an x-intercept. So here's an x-intercept of 2 right there, and this says it's going to be greater than or equal to, so I can make this a solid line up and down at x equals 2. All the points on this line have an x point of 2. Now I need to make the x's that are greater than that, which is going to shade over here. Another way that we can see that is with a test point. A test point can be any point that you pick, anywhere on the graph. I try to pick things that are clearly on one side of the boundary line or the other. This one's pretty clear over here. Let's see what this test point is. 1, 2, 3, 4, 5, 6, 1. So we're going to test the point 6, 1 and the inequality. We're going to plug it in there. 6 is the x. So when I put 6 in here, 6 is greater than or equal to 2. That's true. If it's true, you're going to shade where your line is. If it was false, you would shade the other side of the boundary line. Okay, let's do our y line here. I'll do that in red. It says y is greater than 3. And where's the y of 3? It's on the y-intercept. 1, 2, 3. And a y equation is actually just a horizontal line. This one needs to be dotted because it did not say we were equal to that 3. And then we're going to look at the y's that are greater than 3. That's everything above here. Greater than is always above. And your solution to your system is where these two shadings cross between your two boundary lines. There's the solution right there. Let's do another one that looks a little more conventional than what you're used to. Here's two equations that are mostly in slope-intercept form. If I wanted to make this look a little prettier, I can switch up my x and my y, keeping the x negative and the y-intercept positive. Now let's graph them. Y-intercept is 2. Slope is negative 1. Down 1, right 1. Down 1, right 1. Down 1, right 1. Down 1, right 1. Okay. This is less than, not equal to, so we need a dashed dotted line. If I plugged these points in right here, they would not make a true statement in the inequality. Alright, let's do the next one in black. It's already in slope-intercept form. Y-intercept is 4. 1, 2, 3, 4. And the slope is 1. Up 1, right 1. Up 1, right 1. It is also a dashed line. because it was not equal to. Okay, I like to get my lines on there before I graph, or before I shade. Let's do our shading. Back to that first equation. All the y's less than the boundary line is going to be everything down here. Let's do this test point 0, 0. Plug in 0 for y and 0 for x. Zero is less than 2. That's true. So I will shade everything on this side of the boundary line. Let's do our black one here. Let's use the same test point. You can use different test points if you want to, or the same one. You can usually even use 0, 0 as long as your boundary line isn't going through there. Plug in 0 for y, 0 for x. 0 is greater than 4. No, that's not true. Not true. So it didn't work down here. So I need to shade above the boundary line. Where do these shadings cross? Right around here. Where's my orange and black intersecting? Everything this way. There's your solution right here.